Good afternoon and welcome to our February edition of the Conservation Outcomes webinar series. My name is Liz Marshall and I am the Outcomes Team Leader for NRCS's Outcomes team. The Outcomes team hosts this webinar series monthly to highlight NRCS's conservation outcomes and quantification efforts, as well as to demonstrate innovative conservation planning and assessment tools and to highlight useful data for that effort. The webinars generally take place on the fourth Thursday of each month at 3 p.m. Eastern Time. Okay, we're going to get started with the fun stuff in just a minute, but first I want to go over some logistics. This webinar is being recorded. All participants joining the webinar are in listen-only mode, and all audio is being broadcast through your device's speakers. If you're having problems with audio, sometimes computer or mobile device headsets can help with the audio quality and volume. Sometimes it helps to log out of the meeting and come back into the meeting. And also please note that there is a closed captioning link provided in the box on your screen that's entitled Today's Links. Those captions open in a new browser window and you can follow along with the presenter's comments that way. And although you don't have audio capability, we still want you to participate in today's webinar. So please type any questions or comments that you have into the Q&A box that you will shortly see appearing on your screen. You can submit your questions and comments throughout the presentation, but we will be addressing them at the end of the presentation. Please also note that Adobe Connect provides a connection status bar indicator in the very upper right portion of your screen on the Adobe Connect menu bar. If all your bars are showing as green, that usually means your network connection is strong and you shouldn't have any problem with joining the webinar. But if you do have a weak connection or you have some interruptions in bandwidth, the webinar recording will be accessible through the Conservation Outcomes webinar series webpage, and the link to that site is in the box on the screen labeled Today's Links. Also, please note the presenters for today's webinar have provided a couple of handouts and a PDF of today's slides that are available to download from the box on your screen entitled Today's Handouts. And finally, if you want to make the slide presentation pod larger, you can use the icon in the upper right of that slide pod in order to make the slides appear in full screen. And you can use that same icon to toggle back and forth if you want to enter a question at any point during the presentation. I'm now pleased to turn the microphone over to Louis Tupis to open today's webinar. Louis Tupis is Deputy Chief for Soil Science and Resource Assessment here at NRCS. After the Deputy Chief's introductory remarks, we will turn the reins over to Charlie Rewa. Charlie is NRCS's Wildlife Component Leader for the Conservation Effects Assessment Project, and he will be moderating today's webinar. Thank you, and over to you, Deputy Chief Tupis.
Thank you very much, Liz. Can you hear me?
Yes, we can.
Very good. Thank you. So welcome to this webinar. We started these monthly webinars in April of 2020 as a way to communicate to our stakeholders the importance of voluntary conservation programs and the funding provided through the Farm Bill for these efforts. And we also do it to highlight some of the documented outcomes in terms of natural resource and economic benefits. Today's webinar is a great illustration of how science-based assessments, which is performed by the Conservation Effects Assessment Project, result in tools that not only quantify wildlife outcomes, but also help planners and producers improve the land and benefit people by maximizing production on grazing operations. We're excited to showcase the Rangeland Analysis Platform developed by our SEEP partners at the University of Montana. We'd like to see how it leverages technology and big data to take rangeland conservation to a whole new level. Know that NRCS is already taking action to put this technology to work today. We will soon announce new ambitious plans to restore rangelands at landscape scales through our new Working Lands for Wildlife frameworks for conservation action in the sagebrush and Great Plains grasslands. These strategies both utilize the Rangeland Analysis Platform and result in an approach that empowers producers to effectively manage sustainable rangelands while maximizing economic benefits. Our West and Central National Technology Support Centers are also working to promote use of this tool by producers and to integrate it into the toolbox used by our conservation planners in the field. It is through this integration with our agency tools like the soil survey and the ecological site descriptions that provide scalable win-win solutions for everybody. With that, I'd like to turn it over to Charlie Riwa, the SEEP Wildlife Component Leader, to introduce today's presenters. Thank you very much.
Thank you, Louis, and welcome everyone. I'd like to say a few words about the wildlife component of SEEP before introducing our speakers today. I'll be back at the end to address the questions submitted through the chat. So back in, starting in 2005, SEEP Wildlife Component has been supporting outcome-based assessment through over 80 cooperative agreements with our science partners. And these assessments document how fish and wildlife species and populations respond to conservation practices and programs, but also help to inform more effective conservation work ultimately. One focus area has been documenting outcomes and supporting the science for effective delivery of NRCS's Working Lands for Wildlife effort. And in the West, this has revolved around our long-standing partnership with the University of Montana, beginning with a focus on documenting outcomes of the Sage Grouse Initiative. And that effort has really evolved to address threats and drivers at the sagebrush biome scale, with recent expansion to addressing natural resource threats in the Great Plains grasslands biome. So SEEP Wildlife ascribes to the co-production of science that enlists upfront input from our partners that results in actionable knowledge and better outcomes for conservation. SEEP-supported science-based delivery of Working Lands for Wildlife in Western Rangelands has been producing win-win solutions for wildlife and partners for over a decade. And some of these solutions are illustrated in the new Working Lands for Wildlife magazine, included in today's links, as well as recordings of previous outcomes webinars from last April and August. And Liz mentioned that those links to the previous webinars are also in today's webinar presentation. So a great example of this co-produced science is the emergence of the Rangelands Analysis Platform, or RAP, to be highlighted in today's webinar. So with support of the SEEP Wildlife and SEEP Grazing Lands components, RAP is the brainchild of Dr. Brady Allred, rangeland ecologist at the University of Montana, and science advisor to NRCS for Rangelands Conservation. So available as a free online tool, RAP is increasingly being used by producers, land managers, NRCS staff, and scientists across the West. Today's webinar could be subtitled The RAP in Action. Brady will start the presentation, but we'll also hear from Dr. Dirac Twidwell, rangeland ecologist at the University of Nebraska-Lincoln, who advises NRCS on grassland conservation in the Great Plains. He will share how RAP is being used to effectively target conservation actions, maximizing return on investments from wildlife, ranchers, and rural communities. Collectively, Brady and Dirac have published over 50 scientific papers to inform sagebrush and grassland conservation across the West. So now I'd like to turn it over to Dr. Allred to start the webinar. And so Brady, the floor is yours.
Wonderful. Thank you very much, Charlie. And good afternoon, everyone. Dirac and I are excited that you are here, and we're excited to talk today. But first things first, Dirac and I get to work with a fantastic group of people. And in particular, it's the Western Working Lands for Wildlife team. I couldn't ask for a better group of people to work with. Today, I specifically want to call out Dr. Scott Morford, who's with us here at the University of Montana. Dr. Morford did much of the analysis that we're going to present today, and so he deserves the credit for it. So a lot of the times we get asked, what is Working Lands for Wildlife? And Working Lands for Wildlife, it is not a program, it is not a department or a unit. What it is it's an approach to conservation. And it's an approach that balances wildlife conservation through sustainable agriculture. And when you do that, you come up with win-win solutions or positive outcomes for both wildlife conservation and wildlife populations, and also agriculture itself. Now, today we're here to talk about outcomes. And we all know that outcomes are important. And when we talk about outcomes for conservation, a lot of the times we think of increasing populations for certain species or more sustainable rangeland production. And of course, those things are important, right? Outcomes are important for conservation. That's the reason we do this. But there's a flip side of the coin, and that is that outcomes are also important for people. They're important for families. They're important for livelihoods. And many times, when we have positive outcomes for conservation, we also have positive outcomes for people. So when we're helping people help the land, we're really helping people to create positive outcomes and to help themselves and their families and their livelihoods. Now, the United States is a big place, but it's important to recognize that 1 out of 3 acres in the contiguous United States is rangeland. Now, 80 to 90% of that occurs in the western half of the country. And when we think about western rangelands, a lot of the times we think about public lands. But it's important to note that 2/3 of these rangelands are privately owned. And what that means is this is a tremendous opportunity for this agency to work alongside landowners to produce outcomes. Again, outcomes that matter for conservation and outcomes that matter for people. The other thing we need to recognize is when we think of agriculture, a lot of the times we think of crops or we think of tractors. But on western rangelands, grass is the foundation to rangeland agriculture. And instead of that grass being harvested by tractors or combines, that grass is harvested through animals, livestock. Now, one thing that the department does really, really well is we track our agriculture. In fact, we have a whole agency dedicated to this. Now, tracking is important because when we track things, we know where things are and we know where things are happening. It's kind of like our family's finances, right? When we track the money coming in and the money going out, we know how well we are saving for that killer summer vacation that we're going to take come July. And so the same thing is true with agriculture and conservation. When we track it, we know where we are and we know what we need to do in order to get to where we want to be. Now, as I said, we do a phenomenal job of tracking. What we're looking at here is the 2019 State Agriculture Overview for the state of Kansas. And as you can see for crops, we track those foundational crops, corn, soybeans, wheat, and so on. We give an estimate of their yield, an estimate of their total production. And then we also give an estimate of their value in dollars, an economic estimate. Now, when we move over to rangeland agriculture, we take it up a step and we track livestock. And we do a really good job doing this. But one thing that you'll notice is that we don't track grass. Now, this is important because if grass is the foundational component of rangeland agriculture, there may be subtle things that we may miss or may not be aware of because we aren't tracking it. And the reason we aren't tracking grass is because it's incredibly hard to do, especially at very broad scales. And for that purpose, this is the very reason we created the Rangeland Analysis Platform. Now, many of you have probably heard of the Rangeland Analysis Platform, and many of you have used it or are using it in your work. But I'm going to take a few minutes to talk about it today. So the Rangeland Analysis Platform is actually two things. First, it's a web application, and you can go to the URL on your screen and go and learn about the Rangeland Analysis Platform, use it and do some simple analyses and some simple visualization to see how rangeland vegetation is changing through time. But the thing I'm going to talk most about the next few minutes is actually the data behind the Rangeland Analysis Platform. And that's because that data is important. That's the engine of the Rangeland Analysis Platform. So in order to produce the two main vegetation data sets on the Rangeland Analysis Platform, which are a vegetation cover data set and a rangeland production data set, we actually used on-the-ground plots. So we have 60,000 on-the-ground plots. These plots were collected from the NRCS NRI programs and the BLM AIM programs, real on-the-ground data. And many of you have probably been involved in some of that collection in one form or another. And for that, thank you very much. Without these data, what we're about to present today would have been impossible. These data sets, the NRI data set, is invaluable. While we were collecting that data on the ground, satellites were orbiting the Earth. And what we did is we combined the power of on-the-ground data with the power of the satellite imagery that's available. And through the cloud computing that's becoming more and more powerful every single day, we were able to build vegetation maps of rangeland cover and rangeland production across the entire western United States. And these maps are at the resolution, the medium to fine resolution of 30 meters, which is more or less the size of a baseball diamond. And if you're wondering how many baseball diamonds are out there in the western United States, it's about 5.5 billion. And so for each one of those, we have an estimate or measurement of rangeland vegetation. Now, one of the data sets that we've created is what we're calling rangeland production or herbaceous biomass. This is an estimate of production measured in pounds per acre, and it is separated into perennial forbs and grasses and annual forbs and grasses. And so from 1986 to present, we have an annual estimate at a 30-meter resolution of rangeland production. So we can go back 30 years and for a pasture or a ranch or a watershed or even a county or a state, we can see how rangeland production has changed. We also have that data every 16 days. So within a growing season or within a year, we can see the trends, how vegetation, how production is increasing or decreasing. And we can compare it to past years and see how things have changed through time. Now, one of the important things about this data set is that it allows for a shifting baseline. And what I mean by that is it allows, if something changes from, say, a perennial grass-dominated system to a tree-dominated system through time, this data set will reflect that. And that's important because that allows us to track that foundational component of rangeland agriculture, to track grass. And what Dirac and I are here to talk about today is that when we quantify grass, when we quantify it the same way we quantify those other commodities of agriculture, that can help us improve conservation and improve more positive outcomes, for conservation and more positive outcomes for people. Now I'm going to hand it over to my friend, Dr. Dirac Twidwell, and he's going to show us how he's using these data sets to improve conservation.
Thanks so much, Brady. I just feel really fortunate to talk to everybody today. It's this is one of those major challenges when we're talking about linking data sets to help, different ranching groups on the ground. And one thing I've been fortunate to do is leverage this kind of new science and technology with some of what we fundamentally know on the process of woody encroachment, for example, in rangelands, and start to really answer questions that are fundamental to producers. And I think Brady and I, we go way back. We've talked a lot about the decades of science, in rangelands, those foundations, and we've kind of come back to the same question over and over again, where we've concluded that we were missing one of the most important foundational aspects of what drives really implementation on rangelands, especially to groups of producers like you're seeing in those photos. And that was just how much grass is being produced on my site
and what's taking some of that grass out of production. When we start to have ranch-specific information that's on their areas, instead of just scientific generalities, we can start to really foster large private lands collaborations and co-produce science with them. And that's something that I've really been focusing on more and more the last 5 years as a rangeland scientist, is to go through this process of co-production, leveraging tools like the RAPT, and start to create solutions to some of the biggest threats that we face on some of our last big grasslands that are remaining. So I want to show how we've been putting some of this technology into action, and I want to tie it to one of the most foundational concepts in all of agriculture and show how this profession of range can start to engage the mainstream agriculture and connect that to ranchers on their land. So yield gap is a fundamental concept in agriculture that's really pretty basic. What we're talking about is that on farmlands, there's a potential yield, and we want to try and achieve that potential. That's what really benefits incomes on farmland and their ability to deal with reducing factors or limiting factors. That's what causes loss of production on agricultural lands, and that's what drives the yield gap. So limiting factors are, of course, things like water and nutrients. Reducing factors are things like pests. And that's what drives the difference from potential agricultural production versus what we actually realize and get on the ground. So there's this huge global effort, of course, to take information, understand what yield gaps are on different sites really globally, and to pump technology and innovation into the system to try and prevent yield gaps and then close them before those gaps occur. We don't want to wait to have major losses and these huge resource concerns before we act. We want to prevent those losses of rancher income so that they can really maximize that production. And that's some of the things we've been missing in rangelands until we had this kind of data like the Rangeland Analysis Platform. But it's fundamentally the same thing. We've had decades of science showing this loss of livestock production due to years and decades of woody encroachment. And here's an example of that. Well, of course, what's happening is we've gone from the potential yield on rangelands to where we can get up to a 75% loss of productivity as we go from a grassland to juniper woodland. This is an example from work that Sam Fullendorf did in the Southern Great Plains, and we see the same trend in multiple states. Well, of course, the RAP provides us the ability to not just have that as an experiment. We can now start to track where every site, every baseball diamond is actually at along this trajectory. And woody encroachment, of course, is becoming increasingly recognized as not just a local issue, but a national one facing rangeland. But we couldn't answer that question for individual producers or for national planning groups. How much production is actually being lost on U.S. rangelands? And that's what really drives us. Here's an example of what we stand to lose. This is actually an area where we lost 75% livestock production potential due to woody encroachment. And it's such a slow process. It's what Brady's talking about. It's that shifting baseline. You kind of get normalized to it over time because it's not something that just happens overnight. And a lot of people struggle to realize or imagine that that site used to look like that bottom picture. Well, that's what this technology can start to show and bring us. So let's look at an example. Here's an example of a NRI plot in Oklahoma. And here's an area where in 2014, you can see it's 96% cover of trees, 0% cover of grass. You can see that transect going through it. And I've also had the joy of answering that question of what grows underneath cedar trees, and of course the answer is nothing. Here you have 0 pounds of production. And it's probably hard, just like that picture, to visualize what it used to look like and how this site has changed over time. But that kind of NRI information is really helpful for confirming what's being produced in the Rangeland Analysis Platform and modeling that trajectory. So in the Rangeland Analysis Platform, that baseball diamond that's tied to this site, this used to be a very productive site prior to woody encroachment. You can see how much biomass was produced in the late 1980s. We're talking about more than 2,000 pounds per acre there. And notice that over time, especially starting in the mid-90s and then collapsing by 2002, we have this collapse due to increased trees driving the loss of production, something we see over and over and over again in U.S. rangeland. So it goes from a very productive site to an unproductive site. What we're talking about is that woody encroachment is taking land out of agricultural production. And we want to avoid that. We want to prevent losses in yield. That way we're not having to put so much expenditures to try and reclaim what we already lost. And it gets at that question. Finally, how much grass did we lose to trees and being able to track it? Well, what's great that Scott Morford was able to do is he's able to model over time, what if we kept woody encroachment from increasing on our rangeland? So here's what it would have looked like on this site if we hadn't let woody encroachment increase. And this model shows you year to year what that variability in production looks like. And that's based on keeping it constant since 1990. And of course, here's what we observed. Well, in a yield gap perspective, what we're talking about is the difference between the blue line and the red line. That's yield gap. So that's our lost production potential on this site. That's yield gap. Really simple idea, really simple concept. Having this information, of course, we might have been working with groups in the early 90s to try and prevent those losses. When we look at this, we want to be able to answer that question, though, of not just how much grass and forage is lost, but what does that mean to rancher economics? And so here's the same kind of example. You can see how at that yellow baseball diamond, the Rangeland Analysis Platform shows tree covers increasing over time. At that site, it went from 0% cover to now near 100% cover, just like that NRI plot. And over time, you see that divergence where instead of that blue line, we have now lost a huge amount of yield there. This is actually a place near Manhattan, Kansas in the Flint Hills. Well, what's great about the Flint Hills is we have some of the best economic information. And I like to go around now to different producer groups and ask them, how much is a pound of forage worth to you? So far, the best answer I've received was from Russell Blue in South Central Kansas, who said it's invaluable because it's such a rare commodity. And that's because they've lived through what woody encroachment does and taken land out of production. But of course, Kansas State has agricultural economics documents. This baseball diamond grew 101 pounds in 2019, based on 30.5 cents per pound, which is in that Kansas State work, and simple assumption of utilization, that baseball diamond was worth 88 cents in 2019. Well, that's $4.70 less than what a producer would have had on that place. And it might be like, well, what's the big deal? That's just, $5. Well, there's, of course, a lot of baseball diamonds in the Flint Hills. Now, one of the things I think we want to be able to do is we want to try and prevent and close yield gaps. This is actually an example from the NRCS in Kansas where earlier implementation of practices closed yield gaps before they got as bad as they did in that last example. Notice that tree cover collapses due to a cost share agreement that was done with the landowner, and it closed yield gaps. It restored that livestock and forage production in that area to where we can maximize income potential for that rancher on that site. This is what we want to do as early as possible for groups. And this, of course, was worth $7.40 in 2019. So look at how we can start to track this in a way that really resonates with different rancher groups and speak directly to their site and benefit us in larger planning. Now, of course, individual sites is not really our goal. We don't want to conserve and restore baseball diamonds. Our goal is to conserve rangelands. Everywhere on that map in the Flint Hills of Kansas that you see colored red or maroon there is a place where yield gaps have occurred at some point since 1990. The lost production by not preventing woody encroachment from increasing in the last tallgrass prairie ecoregion of North America was 21.3 billion pounds in 2019. That's how much that place produced. We grow a lot of biomass in the Great Plains, even in our rangelands. The amount that was lost to woody encroachment was almost 1 billion pounds. And this is in our last tallgrass prairie area. Now, like a lot of you, I don't know what that many millions of pounds means. It's hard for me to imagine. So a producer gave me the idea of putting this information like hay bales. So that would be like lining up round bales from Kansas City all the way over to Denver, Colorado. That's a 9-hour drive. And I don't know about the rest of you, like I live in this part of the world, that's not the most popular drive for a lot of people. It becomes a lot less popular if you have round bales lined up for 9 hours and that's all you see. That's 798,000 round bales in 1 year that was lost due to woody encroachment. What I'm saying is this confirms what scientists have said for decades in the Great Plains region. Woody encroachment is the biggest threat to rangeland production of rangeland agriculture. And it's costing producers money a little bit every year at a time. And this is the opportunity cost that we now are trying to fix and try and correct in partnership with these producer groups. What's great about the Rangeland Analysis Platform from a planning perspective, and for a scientist like me that's working with big landowner groups, is we have information on that site and what it means to producers. We have information for the ecoregion so that we can plan at ecoregion scales like I just showed you in the Flint Hills. But we also have information for each county, for example, in the state of Kansas, and how much production was lost in 2019 due to woody encroachment. And we also have it for the entire western United States. Look at those numbers. We lost 40 billion pounds in the western United States due to woody encroachment by not preventing that increase since 1990. That's your number for 2019. That's like taking the production of Montana out of the cattle industry. So this is huge, and it's not just huge, right, for just cattle. That's the foundation for rangeland ecosystem services. Our wildlife depend on rangelands being productive. So this cross-scale information, the fact that we can now document from the site level to the entire nation what's the impact of a reducing factor like woody encroachment is to rangeland agriculture, we can start to really connect with landowner groups in multiple levels and start to plan better on how to solve this problem and have better success. And if I was going to create from this some at least initial philosophies on it, they would be the exact same as the rest of agriculture. Improving conservation planning in rangelands, we should be avoiding yield gaps. We should work to prevent yield gaps on rangeland, just like we do for corn, just like we do for soybeans, just like we do for wheat. We don't want crashes in yield before we act. We want to prevent yield gaps from emerging. And we want to act as soon as possible to close yield gaps instead of waiting to act until systems collapse. And we want to do so at scales that matter. We don't want to just conserve baseball diamonds while we're losing rangeland agriculture. We want to act at large scales and conserve regions. And we want to share those outcomes so that we can show success stories. And for a lot of you that might not know, we do not have many examples of winning with woody encroachment at large scales in the Great Plains, our most productive rangeland system, our most productive rangeland biome. We have success at small scales in general. So these four things right here would be a huge revolution and complete transformation of how we approach woody encroachment. We traditionally have waited to call out the ambulances after woody encroachment took over rangeland sites and our yield and farmer income and rancher income collapsed. We want to move to more preventative care, protect large core areas, and prevent woody encroachment from taking it over and really hurting the pocketbooks and income and really conserving ranching for future generations. That's the foundation, and this, I tell you, this story is catching on. We're seeing huge responses from private landowner groups in the Great Plains because it just makes so much sense to them. These philosophies would absolutely change how we deal with woody encroachment in rangelands for the better. And we've already started some of that communication. And I want everybody to kind of step back with me. We finally have an opportunity to connect data with what ranchers care the most about, the grass connection to beef and their income. We haven't had that question, and that's on us from the rangeland science profession. We haven't been able to talk like the rest of agriculture. We now can. So we can connect what a rancher cares most about and start to communicate production with Beef Magazine, Nebraska Cattlemen, different rural farm television networks. But all the wildlife benefits come with it. By keeping big rangelands intact and productive, wildlife benefit from that in our rangelands. It's the best predictor of where some of our most imperiled species are hanging on. And not just that, other ecosystem services, avoiding rising wildfire danger due to volatile woody encroachment that's taken over systems. Water, other issues like that. We've even connected it with social programs like funding of public education for schools. These outcomes can unite us. Agriculture goes hand in hand with conservation when we're talking about woody encroachment in rangelands. What an opportunity we now have because of these kind of data sets. So to me, I'm just so excited about the potential of where we could go as an entire community. Really excited about people tuning in and thinking more about how we can change rangelands for the better, given what information we now have at our fingertips for the first time. So with that, I'll turn it back over to Charlie. Thanks so much for letting Brady and I kind of share what we've been working a lot with other scientists on this team. Happy to take any questions.
Thanks, Dirac and Brady, for that presentation. We do have a good bit of time for some questions, so I would encourage folks to go ahead and put some questions in the Q&A chat. We've got a couple that have come in. While we're letting folks do that, I'm wondering if Brady or Dirac, if you guys could give just a little bit more context of why we have this problem of woody expansion in rangelands, not only in the U.S. but globally, to give some perspective over the last century, what's going on here, what we're trying to address. Can one of you guys take that?
Yeah, sure. I'm happy to take a crack at that one. And thanks, Charlie, for how you set that up. Woody encroachment is really well known as not just a local problem. It's a global issue. Every rangeland region in the world is dealing with woody encroachment. And yeah, the way I often answer that question is, you know, what we've had happen in rangelands is over time we've changed rangelands and their risk to encroachment. So what this is, it shows a weakness in our management paradigm. Over time, our rangelands are a bit more vulnerable. We have seed sources that we've either purposefully planted or ignored in many areas for often good local benefits, but that provides seed sources that expand into intact rangeland ecosystems. As that expansion has occurred, we didn't get ahead of woody encroachment. We've never gotten far enough ahead of it in our attack plan to where we shut down reproduction. So everywhere you see seed sources, they're throwing seed in the next generation into intact grassland areas. Well, we removed feedbacks in the Great Plains like fire that kept those species at bay, but we don't currently have a management strategy in place to where we keep that reproductive pathway of expansion from just going into intact areas. What that means is our attack plan, we chase the problem like an ambulance that I showed. So we have increased exposure, our landscapes are more sensitive to encroachment, and over time, we've just lost really big intact systems to where there's always a seed source, always exposure to what that threat is, and we've never really totally closed that off. And that's happened really all over the world. You can't just manage your way out of an encroachment problem. We've got to really keep our big systems intact, or there's always the risk right next door to you.
So I guess there was a follow-up question about that. It says, what are the causes of historical woody encroachment, I guess?
Yeah, I mean, in rangelands and especially in grassland systems, you know, today fire regimes have so markedly changed. Many areas are burning, like in the Great Basin, burning more than they ever did, and areas like the Great Plains have burned less than they did. And but those fire regimes and how they operated, one of the things that fire did was it kept, you know, different conifer species like eastern red cedar or, you know, Rocky Mountain juniper. It kept those in check. Where that's changed, we've seen expansion tied to it. So, you know, what we did is we said that fire was a replaceable tool in the toolbox. Well, we now know that that's not really the case. Mechanical removal clears large trees, but it doesn't manage the encroachment process. So I think that's one of the biggest things that changed is just how we've tried to manage woody species, we've just missed a couple things, and we can put that into solutions and win if we start to focus on that more. I think what's great about today's talk is that it was really hard to put winning strategies in place unless we connected it with what ranchers care about, and that's forage production and rancher economics. So I think this is going to start bridging that gap for us as a profession, where proven strategies that work can now be embedded in the kind of outcomes that ranchers really care about.
Okay, there was another question about, can you also measure forage quality, not just productivity, but forage quality in terms of what plants are there?
Yeah, so we did not, just to be clear, we did not measure forage quality. And quality and quantity it's a very important relationship and determines exactly what animals eat and where they eat. And so right now we just measured quantity. It's not perfect, but it's a very good indicator of how much forage is available out there on the landscape. Individual grazing decisions, where an animal specifically puts its head down to graze and what part of the plant it grazes or which leaf it bites off, those are decisions made at that kind of forage quality level. Or it may determine where on the landscape they actually go. Some areas of the landscape may be more productive, more in terms of quality, maybe have greater forage quality than other areas of the landscape. That influences specific animal decisions. But right now we're just measuring forage quantity.
Okay. There were some questions about methods. Like what model was used to estimate herbaceous biomass with and without trees, and what kind of input data were used?
Yeah, that's a great question. I won't get into the weeds too much here on this presentation, but we used a very long-used, very accepted, well-standing light use efficiency model that converts the amount of light utilized by plants into carbon, and then that carbon is converted into above ground biomass. All of those methods are documented and are currently being published and are actually posted online on the Rangeland Analysis Platform website. So if you're interested specifically in how that model works and how we did that, you can read up there. We did compare the model predictions to various sources, actually. We compared it to another broad-scale monitoring data set, the Rangeland Production Monitoring Service, produced by the Forest Service. We compared it to a static data set, meaning that a data set that doesn't change through time, the SERGO data associated with the soil survey data. And then we also compared it to nearly 16,000 on-the-ground plots of production data. And generally, yes, the model works really well. It's never perfect, and if you're looking for to nail that prediction every time, it doesn't get that. But it works very well and provides us with that kind of tracking baseline that I talked about before. Because remember, it's the tracking the grass that's important. If we're not tracking that grass, we wouldn't be able to pick up on these changes, and that model provides that tracking very well.
Okay, I guess this other question here relates to forage quality, talking about herbaceous biomass increases that you're able to document. And how do you know that those are invasive plants or poor quality forage plants? And I guess maybe that goes back to your other answer, but if you had anything else to add about that.
Yeah, that's a great question. And so we don't, particularly parse out is this high quality production, is this low quality production, or palatable or unpalatable production to a specific species of livestock, be it cattle, bison, goats, or sheep, what have you. Because all those animals, they all eat very, very different things. And so, excuse me, I lost my train of thought. And so we don't account for those changes in quality. But then again, when we rent out a pasture, or we don't account for those changes in quality that occur across the landscape as well. what most of rangeland agriculture is built on is that production, the quantity of forage. And so as we go into the future and we get better and better at doing this, particularly at broad scales, where we can parse those things out, across a ranch or a watershed or a nation even, we'll be able to add that and account for those nuances.
Okay, and there's another question here about, have you expanded this to regions outside the Great Plains? And, what other regions have you actually validated models for, and what are the error margins?
Yeah, and so as I said earlier, our models are produced for the entire western United States. So you can say from the Great Plains all the way to the Pacific coast. And when I talked about comparing it to others' data sets and comparing it to on-the-ground data, that covered that entire geography. And so if you go on the Rangeland Analysis Platform, I don't have it in front of me here, but you can look, and we literally have plots, charts, and data that shows the variance and how things compare to those other data sets.
Okay. There's a question about what about the wildlife that depends on trees?
Yeah, that's a great question. I think the overall theme here is, we're trying to preserve rangelands. And so, of course, wildlife that depend on trees is absolutely important. But these areas that we're focusing on, this 1/3 of the United States, are rangelands. And rangelands are areas that are defined by a dominant, herbaceous component, largely free of trees. And so the goal here is to be able to preserve those rangelands and to be able to create positive outcomes for conservation that translate to positive outcomes for people.
Yeah,
Okay.
I really appreciate what you said, and I think it's really important too to connect that with, take the Great Plains, where grasslands were treeless ecosystems at large scales, and recent science papers showing that we lost 700 million grassland birds, and one of the most imperiled, groups of species, anywhere for wildlife. Well, if you look at that yield gap and the lost productivity, it's really easy for us to identify where there were trees that exist in the landscape, how those can benefit, forested type of wildlife species. But what we're losing much more than that is all the areas that require grassland areas. So by being able to put this stuff into a spatially explicit targeting approach, like true conservation planning on landscapes, we can better meet both of those objectives for both the grassland birds that require treeless systems and more forested species that require, areas within our grasslands to have some patches of trees.
Okay. Another question here. How far away are you from creating this level of analysis at a 10-meter resolution? This would be more applicable to improving biomass accuracy for smaller land holdings.
Wonderful question. You have to remember that that sign of resolution has just become, it's that type of imagery, satellite imagery, it's really the new kid on the block. That sign of resolution hasn't been available for that long. Specifically, the 10-meter resolution refers most likely to the Sentinel satellites launched by the European Space Agency a couple of years ago. The satellites that we are using belong to the Landsat missions, and since 1972, those missions have existed. And really starting in the early 80s is when they got consistent, and we've had Landsat missions continuously operating ever since then. And so I think in the future we are definitely going to consider finer resolution imagery from those types of satellites. And as they become more common and more established, we will definitely work them into our models.
Okay, thanks. Here's another question related to some other resource concerns. Have you worked with collaborators to use your data as input for scenarios to evaluate water benefits and outcomes, limiting woody encroachment in the landscape? particularly in riparian areas. That would be another outcome to look at.
Well, I can't speak for everywhere, but you're really hitting on a big effort that's actually I've been part of using these kind of data sets within multiple states here in the Great Plains. And I'd say it's also true for other people on this call, and especially part of the Working Lands for Wildlife team. And, you know, for example, there's areas that are in more of these intact rangelands that have significant amounts of encroachment. And by being able to work with these landowner groups, it's identifying where they're at risk for not just lost production in the past, but where they're at risk on landscape for future losses in production. Because those future losses are occurring near where they have those seed sources and expansion on woody plants. Well, a lot of those areas in the Great Plains and elsewhere are occurring in these kind of watershed and riparian zones. And so that focus on how to tie like these kind of rancher-based economics and forage output with areas that can also benefit other ecosystem services like water has been a really big conversation that's starting to happen and a really great opportunity for the rangeland profession. And I'll say it's not just that. There's targeting being linked to where there's priority areas for, you know, more rare and endangered wildlife, and also identifying areas where we have wildfire risk. So where rancher economics benefit on private lands while also improving water, you know, wildfire danger mitigation, wildlife, that is currently the state of conversations that I'm fortunate to be involved with here. And I know the same thing's happening out west in other areas.
Okay, I'm just trying to track all these questions. There's a bunch of them, not only in the Q&A box, but in the chat box too, I just discovered. Okay, let's see if I can get to this one. I'm not sure what this actually means. Are you monitoring E, G, and S via remote sensing, namely carbon sequestration and biodiversity and habitat? Not sure you have an answer to that.
Yeah, I don't know exactly what, I'm not looking at the question, so I don't know exactly what that's referring to. In terms of carbon sequestration, we are monitoring the pathway of photosynthesis, you know, the amount of carbon sequestered by the plant through photosynthesis. What we are not monitoring, and what I would like to make clear, is that the Rangeland Analysis Platform does not measure or monitor soil carbon in any form or fashion.
Okay. Here's a question about maybe one of the slides. For the 1990 equivalence line, how did you factor in the impact of climate and weather events to calculate what production would have been without tree encroachment?
Yeah, that's a fantastic question. And, you know, because we could have just drawn a line and said, this is what production was in 1990 without trees, and just drawn a straight line. But we know, you know, very well that production varies annually. And if you recall back looking at that slide, you would have seen a dip, particularly in 2011, and that point was in central Oklahoma. And 2011 was a very strong drought year, of course. And so we do account through the modeling process of, you know, modeling production without trees. We do account for those changes in climate.
Okay. I guess this is a related question. When you're determining the baseline to establish a yield gap, what time parameter do you use when working with climate variations and transitional stages underway?
Yes, so we started in 1990 is when we started. So, you know, 30 years ago. And we monitor the climate or the weather, the meteorological variables for, you know, every year, actually every day throughout the year, to be honest. And so we're working at that resolution of climate data.
Okay. Here's one of your favorite questions, Brady. Is there a plan to expand RAP to the eastern United States rangeland, specifically in Minnesota?
Yes, I love that question. The short answer is we're working on it. The reason it's restricted to the western United States is because it is based on where those on-the-ground plots are. And we have, as I said, 60,000 of those from 2004 to present that are western United States. Once we move into the eastern United States, the number of plots that we use for this modeling purpose, they drop off a lot, and we only have a few thousand, to be honest. And so that reduces our capability in the eastern United States. But it's something we're actively working on and thinking about a lot.
Okay. In the Rangeland app, which feature, tree cover or shrub cover, are the most accurate for looking at juniper encroachment over time in places like Montana?
Yeah, so I always tell people it's important probably to look at both, and not just for specific locations. Now, for junipers in Montana, tree cover is definitely the place to start. But in some places, across the West, sometimes trees or shrubs grow up to be big trees, and it kind of depends how things are classified. And so if you're really interested in woody encroachment in general, I would look at both of those and think critically about it and see which one corresponds to my knowledge of the landscape, and then go ahead and use that one. Sometimes you can combine them, and we've had good success with that as well.
Okay. There's another question here. Given that both RAP and RPMS use Landsat data to model biomass production, how is it possible to generate meaningful error estimates for RAP by comparing the two, or is it possible?
Yeah, it is possible. You can compare them, even if you were to, even though they use Landsat, the same Landsat data, you can compare them. They are actually two entirely different workflows and don't use the same Landsat data, to be sure. But keep in mind, you are comparing two estimates of biomass. And if you compare it to the soil survey, you're comparing another estimate of biomass. And if you compare it to on-the-ground data, you're also comparing it to another estimate of biomass. And no matter which data set we use or which method of data collection we use, whether it's, a remotely sensed data set or go out and collect data on the ground, there's always error. And even when we collect data on the ground. And so when we're working with these broad-scale data sets, we just wanted to compare it to other estimates that are available out there. And the really only broad-scale data sets out there are the RAP, the RPMS, and the soil survey data set.
Okay. There were a couple questions that came in about the use of planting windbreaks and, conservation practices that actually, historically have contributed to trees on the prairie. So how are windbreaks for the prevention of soil erosion being factored into the rangeland strategy for grassland productivity?
Sure. Well, it's part of that history of there's a number of rangeland improvements that we've done for benefits over the last 100 years, and some of those improvements also increased risk in ways that were unexpected and unanticipated in the past. And one of the most well-known examples is doing an improvement for wind protection. And so there's two parts of it to reconcile. Like, windbreaks create a local isolated benefit that is very important for a number of producers. And, we can now track woody encroachment into rangelands. We know that the risk it takes, right? Like we showed the billions of pounds of forage lost if we don't keep windbreaks from expanding into rangeland areas. So because we have this data, we can start to have realistic discussions with producers on if you're going to do an improvement like that, how do you better manage that risk? We don't want to have an improvement compromise our ranch. And there's been a lot more discussion of an integrated management approach instead of just trying to tackle one resource concern at a time. That's where we start to get ahead of those. And there's a number of future work coming out on how to have a winning strategy for woody encroachment in ways that even think about windbreaks as creating an isolated benefit, but they do have encroachment potential in a number of our rangeland areas. And where that's the case, think of that as a high maintenance zone in your grassland or rangeland area. The problem is if we ignore it, the number of acres that we start to lose over time, producers then have a hard time of, right, like they don't have all the time in the world and it's expensive to manage encroachment if you wait. If we can just maximize the amount of area that's intact, minimize the amount of area that requires higher maintenance, those localized benefits of the historical tree planting programs can be managed. We just ignored them in the past until it got too late and people had a hard time recovering what they lost. But the spirit of the question is one that I get all the time. And I guess what I'm striking it for is more of a balance and a strategic, smarter approach to rangeland management. We do need to reconcile improvement practices with large-scale rangeland conservation if our ecosystems are going to be here for future generations. And that's a perfect example of one.
Yeah. Well, that's a great answer, and I see we're past the top of the hour already. There are more questions coming in, so I guess I would encourage folks just to go to the Rangelands Analysis Platform web app and just play around with it. And Brady and Dirac, I'm sure, would be interested in hearing from anybody who has feedback. So with that, I think I need to turn it back over to Liz to wrap things up so we don't spend the rest of the afternoon here. So Liz, I'll turn it back to you. Thanks.
Thanks, Charlie. That was a great discussion. I'd like to thank Deputy Chief Tupas, Charlie, Brady Allred, Dirac Twidwell for taking time out of their schedules for today's great presentation. And thanks also to everyone who attended the webinar. We hope to see you again for our March webinar, which will discuss results from the Mid-Atlantic Wetlands Assessment Project conducted through the Conservation Effects Assessment Project. Have a great afternoon.